Welcome back. In this video, I'm trying to show you how you can make a statistical analysis based on the data that you have. In GraphPad, there are two options to do this one. If you just made a figure, for example, by an ELISA, and you want to make sure that that difference, what you see, this is really significant or not. For example, in my case, these were my data here. I was using two types of cells and five different treatments, and that is the graph I made. So I'm curious about that, whether this difference is a real one, or even this one, for example. I think it's pretty obvious that that would be significant, and here as well, but who knows? Let's make the statistical analysis. So every time you need to go work with your data back, the raw data, what you inserted into the table of the GraphPad, and on the top you will see this button set, for example, analyze. With the analyzing of the data, if you select everything and then you click analyze, then the GraphPad is automatically giving you the option which fits the most for your data set. Look at this. In my case, there were two groups and 5 different treatments. So it offers me a grouped analysis in which the two-way ANOVA is there. And in that sense, I can compare the Y type with the KO cells. That's fine. So if I click OK, then I need to give the small details to the analysis. So on the first thing, you need to select the data arrangement. As you see here, there is a preview window every time, which it shows you that the green color are the values. So if you have matching by factors, you have two options. If you click, each column represents a different time point, so the match values are spread across the row. It looks like this, which means that the first value was measured with the first one, the second with the second, and so on. If you click the other one, it will look like this, which means that the time points are like this. And if you click both of them, you will see. This time I'm not going to give anything. I'm go further with the multiple comparison part, because I'm curious about that, how the control treatment and the DMSO is working. So in the case of the multiple comparison, if you click on this one, then you see there are a lot of options. If you go first with the compare the row means, it is basically showing you that the program is calculating the mean value of the row, and then it is compared between the first one and the second, and search from the second, and so on. But the problem with this one, that it is going to involve the KO cells as well, but I don't want that one. So in that case, this is not going to work for me. If you go further, then there's another option, which is within each column, compare the rows. So it is going to calculate the control Y type and the DMSO Y type and the other one, and it is going to compare these two. But however it looks like now, it's okay, but I'm curious about how the KO cells are to be like compared with the Y type. So this is not the way it's going to work. So you could go further, compare each cell mean value. Now it looks okay, because finally you have a comparison between the Y type and the KO, but still there is no connection between the two rows. And if you want to spare some time for yourself, compare the cell means regardless of the rows and the columns, which means it is going to compare everything with everything. So let's click OK. And now you would have the variant analysis, which is the result table like this. Sorry. So what you have here, it says this is the kind of summary table in which you will see that there is an interaction factor, a row factor, and a column factor as well. And in the right part of the window, you see the multiple comparison part. If you click on here, now you see that everything is listed here, like which one was compared with which one, and what about the significant and the summary and everything. So in that case, you just really need to see which value shows you which one. I told you in the very beginning that in my case, I'm curious about that, how the control value is significant or not regarding to the KO and the Y type. So I need to compare the control Y type with the control KO. So I go back to the analyzers. I'm going to use the control Y type with the control KO cell line. Unfortunately, this is not significant, but that's okay. If you want to highlight these ones, because you would have a lot of samples and later on it's hard to find the ones that you need, it's easier if you highlight it. On the top you will see this change, the highlight the selected cells. Now it makes yellow. That's good. Let's go further. Let's see another one. For example, reagent A, the Y type and the KO. Let's go back and let's see. We need the reagent A Y type with reagent A KO. That is also not significant, unfortunately. If you go further, then let's see reagent B. Maybe this will be significant. Reagent B with reagent B. Yes, it is finally. So I would say that that's a good one because the difference was real. And if you go back to the figure, the last one, reagent C, it looks like, let's see how it goes. Reagent C, with, yeah, it is also significant. So as you see, we have 3 asterisks or 4 asterisks. The asterisks are showing you the levels of the significance, and these values in the last column, these p values are showing you that how it is above or like under the preset p-value. Usually when we are using this ANOVA and also a statistical analysis, we use the 0.05 alpha unit, which is, I mean, the value. And if it's under it, then it will be significant. So now, because you have 2 significant values, you just need to draw it on the graph. In my case, I need to put it here and here. So for that, you can use the draw function of it, select the drawing tool, and then you can click on these options. These are the lines with text. And based on the one that you are working with, the line with text without any, headed arrow or even the capped line, that's up to you which one you choose. But there is one rule. If you are choosing the capped line with text, every time you need to consider that the end, like the capped line end, should be in the middle of the column. I'm going to tell you what I'm talking about. So here, if you click on that one, there would be a pencil appearing, and the pencil is giving you the chance to draw. And then you just draw one. In my case, there was 3 asterisks there. But I said that going to zoom in, the end of this capped line should be in the middle of this column. This is the one that you need to follow. So if you increase it, every time the GraphPad is trying to help you, because the dashed line will appear if it's in the middle. In my case, it was not in the middle, so now it is in the middle, and this is how it's correct now. You can do the same thing with this one. And yeah, in my case, there was 4 asterisks. So I'm going to copy the last one and place it in. And I need to adjust that this should be in the middle of the column here and the middle of the column, this one. Now it is okay. Also, it is important to put the non-significant as well on the top. I'm going to use this time a different one, like without the cap line. If you're working with this one, it's not necessary to keep the middle. Sometimes they are using it, but in here, for example, that was non-significant. Also, this was non-significant, and this one as well. So if you are making the significant values and you label it, important to keep in your mind that if you're using the cap line, it should be in the middle of the column. Some of the reviewers are asking you to adjust these ones as well. And the good part here that if you are making the significant values on the figure, then it is going to copy every time when you copy the graph. So if, for example, if you make a layout and you just want to give them two graphs, you can click on here, like, yeah, this is the one I want. And also if you copy this into a PPT, the significant values are also going there. So this is how the significant values can be shown on the graph and marked and copied, but also there are a lot of options to work with the significant significance analysis. If you click on this one, also you can select a lot of different options here in the list, but also there are some multiple comparison tests. These multiple comparison tests are good if you trying to test the hypothesis, but every time based on the number of these cells and the values in the datasheet and the type of the graph that you choose and the datasheet, the GraphPad is recommending something for you. In my case, it was the CDEC one, which is one of the most strict, but if I take to the Tukey one or even to the Bonferroni, then I can change the analysis. It is also going to ask me to change, and as you see, some of the values has been changed in that sense. It's really important to choose the right significant test. That's what people are saying every time, but the good part in the GraphPad that it is helping you a lot. So you don't need to know exactly which test you need to use before you go, but I would say that there is one test which is going to work anytime, and like in any cases, this is the t-test. So if you want to reanalyze your data, for example, here, you can do an analysis, and this is the so-called t-test, which is the student t-test, what you see there, and it is in the column analysis. But as you see in the list, there are a lot of things to work with as an analysis. And for example, here, the t-test from the column analysis, if you click on it, then it is going to make a comparison between the treatment or another group. In here, there are two options, the unpaired and the paired ones. The paired means that you have the same thing, the same amount of values there. And if you just click OK, then it is going to give you that the value is different or not. So now it says that it is non-significant, obviously, because it is now going to give you the comparison between the column A and column B. So it took the whole average of the values and it made a comparison. And also there is some message from the GraphPad. It says that the analysis is designed to analyze data entered on a column data table without subcolumns. But in your case, as you see, you have 1, 2, 3 subcolumns. So the t-test, in that sense, it is not good for you here. So that's why the annual was recommended in the very beginning. So in that sense, first of all, follow the lead of the GraphPad, and also in that case, you can play with these post hoc tests as well. Usually these values will be here, and all the details you will find it in the what is that called, multiple comparison surface. But also sometimes we copy these values into an Excel file to save it for later on, because sometimes reviewers are asking it, and then you can show it that, hey, this is the value what I wanted to show.